Today, we're going to talk about ventilation, in particular the filtration of ventilation air for residences. Today, we're more and more concerned with our respiratory protection. We have two slides here. The first is an absolute beautiful, pristine day in Vancouver where you can actually see forever. Beautiful, clean air. The next slide shows particles. These particles are individually way too small to see, but there's billions of them out there, and they definitely are contributing to our lung problems. Those particles that we have in the smoggy slide are so small they're actually below the visible range, but they're still a threat to the human lungs. This chart illustrates clearly the span from the nanoparticles, the very small ones, right up to rocks. The big ones fall quickly out of the air, so we're not concerned. The small ones we exhale, they're not a concern. In between, in the 0.1 micron to 10 micron, we have what are called lung-damaging particles, about the same size as you have the bacteria. It is those particles that are of our concern, and the new rating system called the Minimum Efficiency Reporting Value, MERV, is a rating system from 1 or 2 right on up to 16, and the ability to take these particles out of the air. And we'll be talking about MERV 8, 11, 13, and 15 later. In the past, we've been aware and only concerned with equipment protection, and as you can see from this very coarse filter full of leaves and garbage, those filters do a good job of the big particles, and that's what we've been concerned with for the last 50 years in residential heating and cooling. We're now getting to the point right now where we start to have to look at MERV 11, 13, 15 filters that are progressively finer and finer media, which take out smaller and smaller particles. With the 15s today are just one small step away from HEPA, which will take out everything in the respirable range, but which are uneconomic in most cases. The 15 being the 13 and 15 are the sweet spots between economics and very good lung protection. One of the important parts of making residential ventilation work effectively is preventing any form of air leakage around the edge of the filter. And that's why these tracks are spring-loaded both for the particle filter and preloaded equally for the carbon filter. No air can get by because it's truly sealed to allow for the variation of different filter sizes, but guarantee that nothing goes by. There is a second part of residential ventilation, which is the odor. We call it the hydrocarbons. It's the odor component of the pollutants in the outdoor air. The fire smoke that we see in a fire season is probably the worst example, the most extreme example of odor in the outdoor air, but it can come from traffic, industrial, agricultural, a million different sources. The only thing that will take out odor is carbon. It's one of the most effective, lowest cost ways of absorbing odor, short of zeolite, which is 4 or 5 times the cost. Activated carbon will absorb these odors, and the shocking thing is that even 1 pound of activated carbon, and we can get 5 pounds in one filter, 1 pound has 300, almost a million square feet of surface area, an unbelievable amount of surface area that the odors will adsorb to the surface and take them out of the air. Very effective for any form of hydrocarbon pollutant. And when you put it after a particle filter, then you make sure that that carbon is not face loaded with dirt. You protect the carbon so it can do its job properly. The Fyner filter has been designed using heavy gauge steel and spring-loaded tracks to ensure that it's rigid and allows zero air to bypass the two filters, particulate and odor. And it has collars of small 8-inch, 6-inch, 8-inch, and 12-inch to allow it to marry with any ERV or HRV where the customer wants higher degree of filtration efficiency than can be put within the constrained cabinetry of the equipment.